Here is question number 4 from the review. It gives you a statement that f of x function is between sandwiched between these two functions, or you can say squeezed between these two functions. And we need to find this limit. Function f of x, you guys notice, is not even given in the question, right? So direct finding limits doesn't work. So I'm going to try to find limit of this left-hand side function as x approaches to 4. That is simple polynomial linear function. So I'm going to simply plug in 16 minus 9 is 7. Let's also try to find the limit of this right-hand side function as x is approaching to 4. So x squared minus 4x plus 7. Again, this is a polynomial quadratic function. So we are going to just plug in 16 minus 16 plus 7 is also 7. So what I notice is both the left-hand side function and the right-hand side function approaches to the same number. So using squeeze theorem says if a function is squeezed between these two functions and both of them approach to the same number, if x is approaching to a particular number, then this limit x approaches to 4 of the function should be just the same value, whatever both of those two functions are approaching to. So this question is a use of squeeze theorem basically. Here is question number 5 from the review. It gives us a piecewise defined function and asks us to find these values. Let's look over one at a time. Part A says find f of -1. Now, f of x is x when there is equality for -1 here. So you're going to use just the function x. X has to be put as -1. The answer of f of -1 is just -1. Next, it's asking about f of 1. For 1, the equality is here. So we are going to use this function. 1 by 1 is just 1. So that is for part A. Let's talk about part B. We need to find limit x approaches to -1 of the function. Remember, whenever we have piecewise defined function and we need to find a limit at a value which is where the function is splitting, you see at these points function is splitting, then you always need to first find the left limit and the right limit. Then only you can tell the actual limit. So let's talk about that. Now, when x is approaching to -1 from left side, that means x is less than -1. So we are getting closer and closer to -1, but from left side. So that means the function used for the left hand side is x square. Okay. So limit x approaches to -1 left side, function used will be x square. And now because x square is a simple polynomial, we can just plug in -1. The answer is -1. Sorry, -1 square should be +1. So obviously 1 here. Let's talk about the right limit. If you're approaching to -1 from right side, that means you're very close to -1, but from the right side, that means it's a little more than -1. For more than -1, we are gonna have to use this part. So function used is x. Limit x approaches to -1 from right side, function used is x. When I plug in, this is -1. And you notice the left limit and the right limit are not equal to each other. So for this question of the function's limit at -1, you're going to answer does not exist, because for the limit to exist, left and the right limit both have to be same. Okay. Before I move forward, I'm going to answer part C. Part C says if the function is continuous at -1. For continuity, you need the limit to exist, and it should be equal to the value of the function at a. Because limit does not exist at -1, for part C, we can answer f is not continuous at x is equal to -1 because the limit x approaches to -1 does not exist. Because the limit does not exist, the function cannot be continuous. So we are already done with part C here. Now I'm going to go back to part B. There was another part to find limit of the function as x approaches to 1. One more time, it's a piecewise defined function. If it's a piecewise defined function, we need to always find left limit at 1 first and the right limit. Okay, let's talk about left limit. Let's draw a number line. There is 1. If you are approaching to 1 from left side, that means you are very close to 1 but from left side. So x has to be little less than 1. When x is less than 1, the function used is this. So we are going to write limit x approaches to 1 from left side, but function used is x. And because x is a simple polynomial, you can just plug in this limit is 1. Let's talk from right side. When x approaches to 1 from right side, that means you are very, very close to 1, but from right side. If you're right side on a number line, that means you are more than 1. That means you're using this function here. So this limit x approaches to 1 from right side, the functions used will be 1 by x. And when I put 1 in here, this is 1 by 1, answer is 1. Because these both are equal to each other, therefore this limit actually is just 1. Okay, so the answer to part B, second part, is 1. And we know that function's value at 1 is also 1. So we can say for part D that limit x approaches to 1 of the function is 1, which is same at f of 1. So f is continuous at x is equal to 1. Okay, so the answer to the part D would be yes.